For our next example, the first thing we want to do is get rid of parentheses, and I do have a set of parentheses up at the top. So I am going to multiply my exponents with the power rule. So I have x to the 2 times negative 3, that's negative 6. In the denominator, we have x to the negative 5. Step 2 says make all negative exponents be positive exponents. So the x to the negative 6 was living upstairs, and I want him to move downstairs because he's not happy where he's living, so I move it downstairs, and now he is positive or happy. X to the negative 5 was living downstairs. He wasn't happy about it, so I move him upstairs, and now he is positive or happy. And then the next thing is combine exponents with a common base using the remaining rules. Now this is a quotient rule, so I can subtract. If I take 5 minus 6, that gets me a negative number. So instead of just always taking the top minus the bottom, what I'm going to suggest is take the large one minus the small one. So 6 is bigger than 5, so 6 minus 5 gets you 1, positive 1. Now, where were the more x's to begin with? There was 5 x's on top and 6 on the bottom. So I'm not going to have you write this out every time. I just want you to think about it. In your head, maybe without even writing this down, think of 5 x's on top, 6's on the bottom. After you cancel them out, where will the leftovers be? Well, we know there's only one leftover, but where is it? Well, it's in the bottom. How could you tell that the leftovers were going to be at the bottom? Well, because 6 is bigger than 5. So if you just put the leftovers wherever the bigger number was, then you can always just take big minus small, and that's a little bit easier, I think. Our next problem has a big parentheses, and we have a negative 3 out here, and that's going to go to every single base in the numerator and every single base in the denominator. So we have 3 to the negative 3. We have a to the positive 12. Negative 4 times negative 3 is positive 12. Then we have b to the negative 3 times positive 3, that's negative 9. And the negative 3 is distributed all the way through at the top. Now I'm going to go and do this at the bottom. 2 to the negative 3. A to the negative 3 times negative 3 is positive 9. B to the 4 times negative 3, that's b to the negative 12. Step 2 is to make all exponents positive. So just do this nice and slow. In the numerator, we have 3 to the negative 3. That's not where he wants to live, so you're going to move it downstairs. A to the 12 is already positive, and he's already happy. So I'm going to kind of think about leaving the numbers in the front. I'm going to put A's in the back, in the middle, and then B's in the back. And hopefully that'll help me keep myself organized. So we have b to the negative 9. b to the negative 9 is not happy where he's living, so you move it downstairs and make it positive. Now in the denominator, I have 2 to the negative 3. It was already downstairs. So because it was negative, it's not happy where it's living, so you move it upstairs. A to the positive 9 was living downstairs, and it's happy because it's positive, so you just leave it downstairs. B to the negative 12 was downstairs, but because it's negative, it's not happy where it's living, you move it upstairs. Now the numbers, 2 to the 3 and 3 to the 3, those you have to work out. 2 times 2 times 2 is just 8 in the numerator. 3 times 3 is 9 times 3 is 27 in the denominator. So that's all you're going to do with the numbers, and 8 27ths doesn't reduce. Now here we have 12 A's in the top, and that's 9 A's in the bottom. So after you cancel out the A's, how many A's do you have left? Well, the hint for the quotient rule says subtract. That leaves you with 3 A's. Where do you think the A's should be, in the numerator or the denominator? Well, they're going to be in the numerator. Why? Well, 12 was bigger. All right, let's do the B's. I have 12 B's on top and 9 B's on bottom. After you cancel all of your B's, how many B's do you have left? Well, just subtract using the quotient rule and get 3. And where does the leftovers go? Again in the top, because 12 is bigger. And that's your answer. On our next problem, step 1 says to get rid of your parentheses. So I'm going to take that and distribute it to both bases. Notice there's only 2 bases this time, m and n. So m to the negative 8 squared is negative 16. I multiply. N to the negative 4 times 2 is negative 8. Notice that these parentheses only apply to the numerator, so the denominator m squared n to the fifth stays the same. M to the 16 was in the numerator, and step 2 says we want to get all of the negatives to become positive. So the negative in the exponent in the numerator is going to move downstairs, now become positive, m to the 16. N to the negative 8 was upstairs, but now you're going to move it downstairs and make it n to the 8. Now I made the m and the n a little far away from each other, just so I can kind of group all the m's in the front and group the n's in the back. In the denominator, we have m to the positive 2. Now, it was already in the denominator. It's already positive, so we're going to leave it there. N to the 5 is already in the denominator. It's already positive, so we're going to leave it there. So if there's nothing left in the numerator, you have to put a place holding 1 there. So we have 1 over m to the 16 times m to the 2. Because there's 2 bases and 2 exponents, that means I add with a product rule. And then n to the 8 times n to the 5, that's going to be n to the 13, again in the bottom, because they already were in the bottom. And that's my final answer. And for our last problem, step 1 says to clear the parentheses, so that's what I'm going to do first. I'm going to take this 2 and apply it to all bases. Now, we have a lot of bases this time. 2 is a base itself. W is a base, X is a base, and Y is a base. So we have W to the negative 2 squared, that's negative 4 when I multiply them. 1 base, 2 exponents means multiply. X to the 3 to the 2, I multiply that and get 6. And then Y to the 2. Next, I have a negative 5 in the exponent, and the negative 5 has got to go to both of its bases inside the parentheses. So we have times x to the negative 20, because 4 times negative 5 is negative 20. And then we have y to the negative 5. Step 2, make all exponents positive. So 2 to the 2 is in the numerator. All of these are numerator, guys, so it's going to stay in the numerator. W to the negative 4, that's going to go downstairs and make that w to the positive 4. X to the 6 is already positive. It's going to stay up there. And then y to the 2, that's positive, it's going to stay up there. I'm spreading these out just so I can organize them a little bit better. In the red, we have x to the negative 20. It was already upstairs. It's not happy where it's living, so you move it downstairs. I'm going to put it in the area where the other x's are, kind of close there. And then y to the negative 5 was living upstairs. You're going to move it downstairs, and I'm going to put it kind of by the y's, just so it's a little easier for me to finish this up. So 2 squared is 4. W, there's only one W, so that stays down there. But there's 2 terms of x in the top and the bottom, so I'm going to have to combine those. We have x to the 6 on the top, x to the 20. If I use my quotient rule and subtract, that gets me 14. But where should those 14 go, in the top or the bottom? Well, we're going to put them in the bottom because 20 is bigger than 16. So if you think about it, if they cancel out, where should the leftovers go? The leftovers should go in the bottom. Now we're going to combine our y's. We have 2 y's on the top and 5 on the bottom. After you subtract using the quotient rule, that gets you 3 y's. Where should those y's go? In the bottom, because that's where the more y's were to begin with. 5 is bigger than 2, so the leftovers should be in the bottom. And this concludes our lesson on integer exponents.